this video we're going to take a look at functions and a little bit of calculus here as well. So in the first question it's talking about a function called f of x, and that's just, remember the notation, the function f depends on x, and this is how it depends on x. X being the input, f of x being the output. And another thing you need to remember is not only is it that x is the input and the output is f of x, but f of x is also connected to y. Okay, so those two are used interchangeably throughout the course. The first question says, find f of minus 3, and then f of minus 2, and f of 0, f of 2, and f of 3. Okay, so all we're doing is we're replacing the letter x with minus 3, minus 2, 0, 2, and 3 in each scenario. The other thing I want to point out, some students get kind of worried about this notation here. Okay, so just to let me read that in full. Let f of x equal to x cubed minus 3x plus 1, where x is an element of the real number set. So all that means is that the inputs that we put into it can be any real number. Okay, what's a real number? It's any number that doesn't have an I next to it, any number that's not imaginary. So for the first one, for f of minus 3, you're going to take out x in each of the positions, and you're simply filling in for minus 3. So you don't need to put that there, but I put it in. Right, so we're going to fill in minus 3. So we're going to have minus 3 cubed minus 3 by minus 3 plus 1. So all I did there was every single time that I saw x above here, I replaced it with minus 3. Okay, so hopefully nice and straightforward. So then we just tidy that up. You can do it in your calculator. If you're doing it in your calculator, please make sure that you are using brackets and the notation in the calculator correctly. So we'll have minus 3 cubed, which will be minus 27. Minus 3 by minus 3 is plus 9, and then we've got plus 1. Tidying that up, I've got minus 27. These two add to 10, so minus 27 plus 10 is minus 17. I'll do the next one. So we've got f of minus 2. So finding f of minus 2 is going to be, we fill in minus 2 instead of all the x's there. So it'll be minus 2 squared minus 3 by minus 2 plus 1. Tidying this up, sorry, that's minus 2 cubed, my apologies. Minus 2 cubed minus 3 by minus 2 plus 1. So this will work out to be minus 8 if you've used your calculator correctly. Minus 3 by minus 2 is plus 6 plus 1. Then I'm going to have minus 8 plus 7 basically, so I've got minus 1. The next one, and I am going to do them all out and you'll see why in a second. Not only just to answer the question fully, but it's worth me doing it out now for you, because later on we're asked to graph it and you'll see how this connects back to the graph. So f of 0 is going to be 0 cubed minus 3 by 0 plus 1. 0 cubed is 0, minus 3 by 0 is 0, and then plus 1 is just plus 1. Then we have the next one, which is going to be 2. So I'm going to fill in f of 2. And we're going to have 2 cubed minus 3 by 2 plus 1. Again, all I'm doing is replacing all of the x's in the function with the number 2. Doing this out then, we're going to get 8 minus 6 plus 1. Well, 8 take away 6 is 2. 2 plus 1 is going to give me 3. The next one we had was f of 3. It's the next and final one, I believe, so I'm going to do that one out, and I'm keeping my calculation again as neat as I can, because I actually am definitely using it again this time, but often in the exam you do need to come back to use an answer that you previously worked out. So in this case, f of 3 is going to be 3 cubed minus 3 by 3 plus 1. 3 cubed is 27. 27 minus 3 by 3, which is 9 plus 1. So 27 take away 9 will give us 18. 18 plus 1 will give me 19. Okay, so that was the first part done, and hopefully that's something that you remember from junior cycle, whether you did higher level or ordinary level at junior cert. All of us had to be able to do that, where you are given the name of a function and they ask you to take out the x and you start replacing it with the various inputs, or we often call this the domain. Okay, just to give you the official terminology here, the domain is the output, or the input, apologies, and the range is the output. The next one then is find f prime of x, the derivative of f of x. Okay, another thing to note here is that in the same way that y and f of x are interchangeable, so a little note for you here, in the same way that y and f of x are interchangeable, dy dx, which is what you would have initially looked at when you came into the world of calculus as the change in y over the change in x, that symbol or notation is interchangeable with f prime of x, and both of these mean the derivative. Okay, so that's just a little note for you there that you should remember from when you did calculus the first time around. They're used interchangeably and these are used interchangeably. If the question gives you a function in terms of y, it's best practice to follow up with dy dx. If a question gives you f of x, it's best practice to follow up with f prime of x. So they've given me f of x, and for myself, to make this a little bit easier, I'm going to write out what that function was again. So it was x cubed minus 3x plus 1. So I'm just going to do that. So x cubed minus 3x plus 1. And do take your time on things like that. Do make sure you go back and check what the function was, because it would be an awful shame to lose marks because you didn't transfer it down correctly or transcribe it correctly. So now we're going to do the derivative, and you need to remember the little kind of chant, multiply down by the power, take one off the power. And for ordinary level, that's as far as you go. You don't need to know any of the other special rules. It's just the derivative of things like this, the polynomials. So we have f prime of x, and the rule is multiply down by the power. So it becomes 3x, and then we take 1 off the power, so that 3 becomes a 2. Then we're going to have take away 3, and this is where students get caught out, this currently right now doesn't have a power written to it. It is actually a 1 right now. If there's no power, it's a 1. It's a hidden 1. What we do with that 1 then is we multiply down, so it'll be 3 by 1, and then we will have x to the power of, it was 1, we take 1 off the power and we get x to the power of 0. The last thing is a constant. It's got no x in it. And if it has no x in it, then what you have to remember is that it's going to be the rate of change of a constant. And if something is constant, then it's 0. So you don't write that down again, because it's got no rate of change. It doesn't exist. Now, this isn't going to give us full marks, because I need to tidy that up, and you should remember, and this is something that it is in your log tables on page 21, but it's also just good, I think, to have some things in your mind. Anytime you see x to the power of 0, it can be replaced with the number 1. So that's what actually is going to happen here. I'm going to replace that with the number 1. So we're going to have 3x squared minus 3 by 1 is equal to 3x squared take away 3. The next thing to note here is just that you make sure you have your notation. They just wanted us to have the derivative. Make sure you've given back the correct notation to them. Okay? Let's look at the next part of this exam paper question, which, if you're interested, it's the 2010 paper. It would be applicable to the new exams as well, under the section A questions, which are the kind of concepts and skills, rather than the context and application. So this would be one of the 30 markers that you're used to seeing in the most recent papers. We found the derivative, so that's okay. The next one is find the coordinates of the local maximum and of the local minimum point of the curve. Okay, so here's another thing you need to commit to memory. whenever we are at the maximum or minimum on a curve, or any function, what we know is at those points, at the absolute extremes, the rate of change, or we can also think of it as the slope of the tangent to the curve at those points, that's 0. So there is no rate of change when you've maximized it. There is no rate of change when you've minimized it. We also know by connecting it back to the idea that the dy dx finds the slope of the tangent to the curve, right? Tangent being a line that touches it once. We also know and should know that that slope is equal to 0, because look at that line, it goes straight across. So the slope of the tangent of the curve at the maximum minimum is 0. And remember, dy dx is used interchangeably with f prime of x. So this is something that I would be committing to memory if I were you. It's not in your log tables, it's something that you need to remember. So when you're at the maximum or minimum, you know for a fact that the rate of change is 0. And what's the rate of change? The rate of change is that f prime of x. And you also need to remember that the rate of change could be written as dy dx. Okay, both of those mean the same thing. Two ways of writing the same thing. Okay, so what does that mean for us? Well, you have to be very careful at this stage that you take the right function. So I'm going to take this one here, and I'm going to have that was the derivative. So we don't take the original at this point in time. We want to say that the derivative is equal to 0. Right? So that is the derivative, and I'm going to set that equal to 0. Now, often in an ordinary level exam, and sometimes in the higher level paper too, the dy dx, letting that equal to 0, just writing this, or when it's f prime of x, writing that can get you 40%. Because it's showing understanding of the question, that you understand this is a calculus question, and you understand that when we are at the maximum or the minimum of a function, the rate of change is 0. Okay, so that's why you get 40%. It's not because they're trying to make it easy on you, it's because by doing that you've shown a massive level of understanding of the question. So we have f prime of x is equal to 3x squared minus 3 is equal to 0. This is a question then that I need to solve. Okay. And what I'm going to do for myself is I'm going to say, let's divide everything through by 3. See the way there's 3 in common. So let's say divide everything on both sides by 3. To simplify it. Then I get x squared take away 1 is equal to 0. Now, you might recognize that as a quadratic, and if you like and prefer to always use the minus b formula, you can use the minus b formula here. So if you wanted to, you could go and use the formula here. So minus b plus or minus the square root of b squared minus 4ac all over 2a. You could use this. When you use this, you need to remember that when you're getting your key, A, B, and C, A is the number in front of the x squared, which is 1. B is the number in front of the x term. But notice how there is no x term. So if there is no x term, then B is going to be 0. Okay? And then C is going to be negative 1, because that's the constant. Alright, so you can of course use the minus b formula to solve that and continue on this way. The actual nicer way of doing this one is to use your factorizing skills. So you should also be practicing the process of solving a quadratic using factorizing. So this to me is a square number take away 1, which you should know that 1 itself is a square number. So all of a sudden, I have a square number take away another square number. Okay. And whenever I have that, I have the difference of 2 squares. So I'm going to have to follow a formula. And I'll write it up here for you. When you have a square number, take away another square number, it goes to a minus b, a plus b. Every time. That's a little formula you can remember if you want. So that's how it breaks down and it factorizes. And you can just follow it by there's our a, and our b then is the 1. Okay, so we're going to have x take away 1, x plus 1, and it's equal to 0. Then at this stage, you have two things that you don't know the value of, but you do know that when you multiply them together, it's equal to 0. Now, what does that mean? If I ever multiply a number by something, so let me give you an example. I'm just going to scroll down here for a second. Let me give you the example of 7 multiplied by some mystery number, and I get 0 as the answer. And I ask you, what's that mystery number? What does it have to be if I multiplied and got 0? You can test it out with different things in your calculator, but the only way that that could work out to give us 0 is if this number here was 0. So I know that that has to be 0. What if I had a mystery number times 11 and it equals to 0? Well, again, the only way you can ever multiply and get 0 is if one of the numbers themselves is 0. So that's 0. What if you had 2 mystery numbers and the 2 mystery numbers multiplied together to give you 0? What do we do then? Well, we say that one or both of them had to be 0. And in fact, that's exactly the scenario we have right now, because to us, the box isn't written as a box with a question mark in it. It's written with brackets with things in the inside of the brackets that we don't know. But I could, if I wanted to, I could just write that as this. It's the same thing. It's a mystery number to me. I don't know what it is. So I have 2 mystery numbers. They multiply together to give me 0. That means that either the first one was 0 or maybe the second one was 0. Okay, then I want to get x on its own, so I'm going to have x is equal to, I'm going to add 1 to both sides, get 1. This one, we're going to take away 1 from both sides, and I get x is equal to minus 1. Now, in this question, we've done a huge amount of work, and we always need to go back and reflect. Did I answer the question fully? Okay? Always. Please make sure you're doing that. That's a big thing that students lose out marks for. So I've gotten x is equal to 1 and x is equal to minus 1. If you run through the minus b process, you will get the same thing. Okay? In this case, I do think this was faster, the factorizing side. You also have to be able to factorize on its own, whether it's part of an equation or not, so it's good to practice that sometimes too. But let's look back. I was answering part 3 of that exam paper question. Have I answered the question fully? Let me go back up and check. So the question was, again, find the coordinates. So coordinates means that I need to find an x value and a y value. I need to have an x and y. I do have an x value. I have 2 of them. And the reason why I have 2 of them is because of the fact that there is a maximum and a minimum. So there will be 2. But I didn't find the y coordinates yet. Now, to find the y coordinates, we need to go back to what is y. Y is, remember, f of x. So I actually need to take the original f of x, which connects us back to y. Look, they even tell you there, y is equal to f of x. We're going to connect this idea of our x is equal to 1 and our x is equal to minus 1. We're going to connect that back to the original function now to get y. This is a place where students often go wrong. Okay, they'll often lose marks here because they will fill it into the wrong thing. If you want to figure out what y is, you need to fill it back into f of x. Okay, you need to fill it back into f of x, not into f prime of x. And that's where students go wrong. So remember, f of x here, that's what we had in the original question. And the reason why we want that is because that is y. F prime of x isn't y, f prime of x is dy dx. So be careful at this stage which one you bring back. So this next stage is the same as what we had before. We actually have x is equal to 1 and x is equal to minus 1. Okay? This is the same as actually the first question that we did. If we have f of x and we want to get the value for y, we need to know x. Well, we know x is 1. So let's, in this case, fill in x is 1. So we're going to get f of 1 is equal to 1 cubed minus 3 by 1 plus 1. And we'll get 1 minus 3 plus 1. And I'm going to get 1 take away 3, which is minus 2 plus 1 is going to be minus 1. So the coordinate, so for full marks here, for top marks, you have to record it as a coordinate. Coordinates always go x value first, y value second. So 1 minus 1. The next one that we're going to do is if we have minus 1. So we're going to do f of minus 1 is equal to minus 1 cubed minus 3 multiplied by negative 1 plus 1. This works out to be a negative 1. Be careful in your calculator that you've put it in correctly. Then we're going to have negative 3 by negative 1 is plus 3 and then plus 1. I'm going to have minus 1 plus 3 is going to give me 2. Add on another 1 which gives me 3. To get full marks, I need to write my coordinates, which is going to be minus 1, 3. Okay, so there we go. That's the coordinates of the turning points. Right, the next step though, would you believe, we're still actually not done. So these calculus questions can be quite tough. Now, this was in 2010. They didn't scaffold the question or kind of support you in the workings here. In most recent years, they kind of do. They kind of help you out sometimes. Not all of the time, but sometimes. We've just got the coordinates, but one of them is going to be the maximum, and one of them is going to be the minimum. And how do we know which is which? That's the next catch. Okay? That is the next thing that we have to figure out. We have the coordinates, but how do I know which is the maximum and which is the minimum? So this is another thing in calculus you'll need to recall. The max and the minimum. How do we talk about them? Well, let me go back up and get my graph here, because I'm going to use this again. So we know that for starters, that at both the maximum and the minimum, the first derivative is equal to 0. But what if I started to talk about the second derivative? So that's what we actually need when we talk about which is the max and which is the minimum. So to talk about the maximum, what's going to happen is that graph, or this slope of the tangent of that graph, or the curve at that point, this starts to tip down immediately after it reaches the peak. Do you see that? So immediately after I reach the peak, my graph's actually going to start sloping downwards. So I could keep drawing those lines in, those tangents, but what's happening is the slope starts to tip down. So that means, how is it changing? How is the slope changing? So the slope, remember, was dy dx. And if I want to talk about how the slope is changing, then we need to get the slope change, which is the second derivative. So d2y dx squared. Okay, that's just the second derivative. It's just the notation for it. Don't panic. It's the notation for the second derivative. And what we know is that when you're at a maximum, the slope is changing by becoming negative. It starts to tip down. The slope becomes negative. So how do we say that in maths language? If something is negative, we're going to say that it's less than 0. So if I get the second derivative at a particular point, and it works out to be negative, then I'm at the top and I'm starting to come back down. So then I'd be at the max. If we look at the minimum, and we look at the second derivative for that, so how does the slope begin to change after we're at the minimum? It starts to tip upwards. So it starts to become positive. And what type of numbers are positive? Well, this is numbers that are greater than 0. And that's what the minimum is. Now, that's kind of conceptually what it is. That's the notation for it. Remember, dy dx is f prime of x, and the second derivative is just written as f, let me write the f so you know it's an f, prime, double prime of x, so 2 prime of x. And that, we want to know, when is that less than 0? And when it's less than 0, it means it's starting to tip downwards and we were at the maximum. The other one here, again, look, you're going to have f double prime or f2 prime of, oops, sorry, wrong notation, prime of x is going to be greater than 0 because it's going to start going up, the slope will be positive. All right, that's the theory. Let's put it into practice. So what we actually need to do is we need to get the second derivative, right? So remember the function itself. The function itself here was f of x is equal to x cubed minus 3x plus 1. The first derivative we got earlier on, if you remember, multiplied down by the power, take 1 off the power. This is a 1 multiplied down by the power, we go minus 3, take 1 off the power to the power of 0. Constants, gone. Okay. This we simplify further to 3x squared, and you will remember, and you have to remember, that x to the power of 0 is 1. So we're going to have 3 by 1, which is just 3. So we get 3x squared minus 3. Okay, the next piece then that I need to look at is the second derivative. So this is what we call the first derivative, and that's used to find the slope, simply the slope of any tangent to the curve. To talk about whether it's a maximum or a minimum point, though, we need to get the second derivative. So we basically take this and we do the process all over again. So we're going to take that, we're going to multiply down by the power, so we get 6x, take 1 off the power to the power of 1. Constant, gone, because the rate of change of a constant is 0. Okay, so the second derivative is 6x. Now, how do we use that? How do we use that to check which was the maximum and which was the minimum? So you'll remember I got 2 points. We got 1 minus 1 and we got minus 1, 3. And I'm trying to test out which one is the max, which one is the minimum now. So to do that, I'm going to take the second derivative, which we just found, and I'm going to fill in the x coordinate. So the x coordinate here is 1. So I'm going to go the second derivative, fill in 1. So the second derivative is 6x. So I'm going to have 6 by 1. 6 multiplied by 1 is going to be 6. 6 is greater than 0. So remember what we said. If it worked out to be greater than 0, then we had a minimum point. So I've just confirmed for everyone now. So therefore, it's 1 minus 1. 1 minus 1 is a minimum. Because that's what this means. The rate of change of the slope is 6, so it's going to start going up. Immediately after we've hit the peak or the lowest point, it immediately starts going to a positive slope, which is greater than 0, so we must have been at the bottom. This one, we should still confirm for them. So we're going to get the second derivative formula, which we just worked out up here. f2 prime of x is equal to 6x, so I'm going to have to sub in 1 or negative 1 this time. So I'm going to sub in negative 1. So I'm going to have it's equal to 6, and then instead of x, I'm filling in minus 1 this time here, and then I'm going to get 6 by 1 is minus 6. negative 6 is less than 0. And if it's less than 0, that means you were at the top and you're starting to come back down. So that means you were at the maximum. So then we can say, therefore, that little triangle symbol means therefore, we have minus 1, 3 is a maximum. All right. Lots of work involved in that one short bit of a question, but I feel that in recent years they've been a little bit kinder to ye in the papers, in that they might set you up by saying, find the first derivative, find the slope. Find the maximum, find the minimum. Then find the second derivative, which is this notation, and then they'll come back and they'll say find which one is the max and which one is the min. So that's a really important summary there that you need to know and remember. Now it should be intuitive. Like, the symbols are very daunting, absolutely, but it's just because you're not used to reading them. I'm used to reading them, so for me, I look at that and I go, oh yeah, I know what that means, it's the second derivative. You just need to tune your brain into that to read the second derivative. It's a new symbol, it's a new bit of notation. Think of maths notation as trying to learn sheet music. You just have to learn how to read it, okay? The last one then was to plot the graph, okay? So it said to sketch or to draw the graph of the function in the domain minus 3 to 3. So see the way I read that there? That's because I've trained my brain to read it that way. But if you want to read it literally, like word for word, we'd say x is greater than or equal to minus 3 and x is less than or equal to 3. Now, the beautiful thing about this question is that we've already actually figured out what all of the values are that we need to plot, because at the start they got us to fill in minus 3, minus 2, 0, 2 and 3. We actually, in the process of answering this question, we figured out what the deal was with 1 and minus 1. So all we have to do now is I would get a little summary table for myself before I plot it. And you can get this in your calculator as well. But for this sketch of the graph, right, I would say, right, what was my x? What was my f of x? But remember, f of x is equal to y. Okay? And we want to start at, they said, minus 3 to 3. So I'm going to go minus 3, minus 2, minus 1, 0, 1, 2, 3. And then what I'm going to do is I'm going to go back up and I'm going to check all the values. Remember, we actually got these last. So minus 1 was at 3, so I can write that down. 1 was at minus 1. And then we just go back up and check our values from earlier. So you just flick back to question 1 for you. So we've got minus 3 is minus 17, then to minus 1. So we go minus 17. So we go minus 17, minus 1. And then we want to get 0, 2 and 3. So let's go back up, get 0. So when it was 0, it was plus 1. 2 was 3. So we go 1, 3, 19. So we're going to sketch that out then down here. 1, 3 and 19. Okay, so this then, if you want to add a little extra column for yourself, because that's how it'll read in your calculator, by the way, if you do use the table mode in your calculator, what I would do then is just for myself, I'd take my time and make sure I've got the coordinate pairs. So we're going to plot minus 3, minus 7. We're going to plot minus 2, minus 1. We're going to plot minus 1, 3. We're going to plot 0, 1. We're going to plot 1, minus 1. We're going to plot 2, 3, and 3, 9. Okay. So just move those down so they're somewhat more in line with what we were talking about. So there we have them. And now what we're going to do is we're going to sketch it out. So you need to use graph paper. So I'm going to temporarily switch my template into graph paper because I want to model best practice for you. So we want to use graph paper for this, and I'm going to zoom out so I can see that on the screen at the same time. And I'm going to have to draw my x and my y axis. Please use a ruler if you're drawing these in the exam. Okay. Now we only want to go from on the x axis minus 3 to 3. So I might do every 2 boxes to stretch it out. So I'm going to do minus 1 would be there. Minus 2 would be here, and then minus 3 would be there. 1 would be here, 2 would be here, and 3 would be here. Okay, and I'm spreading it out rather than doing every box as one, because it just makes it a little bit easier for me to draw out the box. I probably need a little bit more space considering we're going to go, that should be 19, shouldn't it? Apologies, let me go up and change, that should be 19. Let me confirm again, let's go back up, we got 19, yeah, that should be 19. That's 19 and that's 19. And this should be not minus 7, is it minus 17? Minus 17. Okay, so I want to go to minus 17 on the lowest, and the highest I want to go up to is 19. I would say for that, I would do every one box. Okay, I would say every one box is 1 on the y-axis. So I might even need to rub this part out, and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Need to move it down again. Now I'm cheating because I'm doing this on the computer, but you would need to kind of map it out yourself before you start. So we had 1, 2, 3, 4, 5, 6, 7, 8, 9. I need to move it down again. 10, 11, 12, 13. Down again. 14, 15, 16, 17, 18, and then 19 would be up here. Okay, and then we need to go down to minus 17. So I'm going to go down this way, so down to 17, and I'm going to have minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, just down here. Now, minus 15, minus 14, minus 13, 12, 11, 10, and 9. And now we're going to just plot each of them onto the axis. So we've got 3 minus 17. So go to 3 and go up to go down to minus 17. So minus 3 minus 17. So we have here minus 3 minus 17. There's the first point. The next one, minus 2 minus 1. So go into minus 2, which is here on the x, and then up to minus 1, which is here. Then we're going to have minus 1, 3. So minus 1, and we go up to 3. Positive 3. Then the next one we're going to have is 0 goes to 1. So 0 on the x-axis is here. And we want it to go up to, let me confirm again, 0 goes to just 1. Okay, so 0 and then 1, that's where we are. For the next one, we had 1, which goes to minus 1. So I'm going to go to 1 on the x-axis, but it goes to minus 1 on the y. And then we have the next one, which is 2, which goes to 3. So it's coming back up again. So 2 goes to 3, so we go back up to here, and then 3, I remember from earlier on, it goes to 19. Okay, so 3 goes up to 19, which is this line here. Then what you have to do is you have to connect up all those points. Now, do not use a ruler when you're sketching a curve like this. So a cubic is a curve. When you're sketching a curve like a quadratic or a cubic, don't use a ruler to connect the points. You should be using freehand to connect the points as best you can. I can never do this on the computer, so bear with me. We connect them as best we can. Like so. Okay, so you'd do a better job, hopefully, yourself with the page. It's not so easy to draw it on the computer like this, but you draw those freehand. Okay, do not use a ruler. All right. If you wanted to have more points, you could go for the half steps if you wanted, in your calculator, or you could just do like, what should I be at when I'm at minus 2.5, and it might just give you more points in between that might help you to sketch it. So that is the sketch of the graph. And if you have a look, remember earlier on we talked about the maximum and minimum points. Look, there was the turning point at minus 1, 3, and here was the other one that happened at minus 1, or 1 minus 1. All right. And those are what we call the local minimum and local maximums. The reason why we call it local minimum and local maximums is because, look, that goes way off up there and it's way higher than what this was. And this goes way off down here, which was way lower than what this was. So the other ones are just called local minimums and local maximums because they're not the absolute max and absolute minimums. So that is a very quick revision of a Section A style question that could be asked on paper 1 relating to calculus. Calculus, as you know yourself, comes up in Section A and Section B. This gives you the concepts and skills, so you now should be able to go and work on most of the questions on the Section A parts of the exam based on this. There is one more key skill that you need to know, and I'm going to put that in a second video for you, and that is finding the tangent, or the equation of a tangent to a curve, which is another key skill that's relating to calculus, and it's another one that would come up in the concepts and application stages. So do check that out in part 2 if you're in the process of revising your calculus.